Good morning, everyone, and welcome to another webinar hosted by Goodroads. My name is Amin Minena. I'm the coordinator of technical programs and research at Goodroads. I'll be your host and moderator for today's webinar. Just a quick housekeeping items before I introduce the speakers. There's a Q&A function at the bottom of your screen or at the top of your screen, depending on the Zoom app that you're using. You may, and you're encouraged to ask questions, to type them in as you go along during the webinar, and we'll answer questions at the end of it. So typing your questions as you think of them, and if you want to type them at the end, that's also fine. We'll address all questions at the end. And those questions that we can't get to, if time was an issue, we'll forward them to the speakers, and they'll be able to contact you afterwards. So today's webinar is Sustainable Steel, Wildlife Conservation, and Carbon Footprint Reduction. The webinar will discuss the profile coatings, durability design overview, sustainability studies, and will also educate all attendees on carbon reduction initiatives from the world's largest steel and mining company, ArcelorMittal. Our presenters today are Ray Wilcock, who's the executive director of the Corrugated Steel Pipe Institute, and Stan Lipkowski. Lipkowski is a metallurgical engineer and has been working at ArcelorMittal Dofasco for 19 years from now. So with that, I won't take more of your time. Ray, the floor is yours.
Thank you, Amin. And thank you to each and every one who is attending today. I'm just going to share my screen. I hope that everybody can see the 61st annual anniversary celebration of the Corrugated Steel Pipe Institute. All good, Amin?
Yep, all good.
Okay. What we're going to cover today is quickly I'll explain who the CSPI is, go through the standards, profiles, coatings, durability, talk a little bit about design. I want to get into a little bit about Animal Crossing and fish passages. Stan Lipkowski is going to come on and talk about carbon reduction plans for ArcelorMittal, and I'll finish off with the carbon footprint of corrugated steel pipe. The CSPI, or Corrugated Steel Pipe Institute, is an association which represents the manufacturers of corrugated steel pipe and structural plate. Armtec and Atlantic Industries are both nationwide players with plants from Newfoundland all the way out to British Columbia. Hubcap and Frontier are regional players in Ontario and Alberta. We also have as members ArcelorMittal, the largest steel producer in the entire world. We have Advanced Coil Industries. They produce coatings for corrugated for polymer laminated steel. Ironside, they make machines that produce corrugated steel pipe. Cleveland Cliffs, out of the United States, they produce aluminized steel. They're a large steel company out of the States. Leland Industries manufacture nuts and bolts for structural plate, and Warner Custom Coatings produce a coating that goes onto the structural plate to form a polymer coated structural plate. We also have members outside of Canada, like Bell Group, and 2xO is in Paris, France. Rondell is in Australia. CMP is in Australia. Biocon is in Poland and other parts of Europe. Marmac is down in the United States, out of South Carolina, and Birkenhoek is in the Netherlands. And there's a lot of sharing that goes on between these companies and the CSPI. They at times rely on us for some of the research we're doing, and we also learn from them on some of the things that they're doing in their different countries. So there's a good sharing of information right around the world. The material codes for corrugated steel pipe that we go by in structural plate is CSAG 401, and also some of the American standards under ASTM. It says there G401-14 it is under review. and it is being updated, and we expect to publish that sometime later this year or early next year. So we have a number of changes that we're making to bring it up to today's environment. With regards to corrugated steel pipe, there are 5 different corrugations, starting with the smallest at 38 by 6.5, all the way to 125 by 25. So we're talking about 125 millimeters crest to crest, and then 25 millimeters crest to the valley. And this spiral rib in here, the middle one, that is for storm sewers. That is a smooth wall pipe with a Manning's flow of 0.012. And there are the profiles there, as you can see. So it's smooth wall inside, ribbed on the outside. With regards to structural plate, there are 5 different corrugations, starting at 152 by 51, going all the way up to 500 by 237. So we're getting into deep corrugated plate structures. A lot of these deep corrugations started in the late 90s, early 2000s. When I joined the industry back in the 80s, all we had was 152 by 51. And slowly but surely, through research, through development, deeper corrugations appeared, and it allowed structures to go much bigger than what we could do way back when. Here's a picture just to show you of the difference between a 152 millimeter by 51 to a 400 by 150. So you can see the deeper corrugations here on the bottom versus the one on the top. And by going deeper, it increases the stiffness. It's almost a rigid pipe in many ways. It stands on its own. You don't need strutting or plumb bobs or supports like we did when you get to big spans for, say, the smaller corrugation, and the load resistance up above. It's able to handle a lot more. With regards to durability for corrugated steel pipe, we've done extensive testing for the last 30 years to come up with a chart with regards to how long does it last and what type of environment. So we have galvanized, aluminized, galvalume, polymer laminated, and then we have 75-year design service life. And if you look down the side, you'll see the coating of those particular materials, like galvanized 43 micron zinc coating. Design thickness, 3.5 for galvanized, going down to 1.6 to polymer. The pH levels where it performs, the resistivity, as you can see when you get into polymer laminated, it performs in almost pretty well any environment. And then the chlorides, which are mainly salts. In that particular area, mostly salts. There are others that for agricultural runoff and so forth, but it is mainly road salt that we're concerned about. And we have a performance guideline, technical bulletin number 1 and also 13 for structural plate. And there are figures like this. That may be hard to see, but what this does is it's a chart. When water is measured for pH or resistivity is calculated, or we measure water for hardness or chlorides, we're able to go to our chart and determine what material is suitable for that particular site in Canada. The design codes that we use for anything less than 3 meters in span, we use the CSPI handbook. We also use provincial standards, specifications, AASHTO, and ARIMA. For anything greater than 3 meters in span, when we get into the larger structures, we use the CHBDC, the Canadian Highway Bridge Design Code. It provides a more thorough approach to design based upon ultimate strength principles, and it better addresses the deep corrugated structures and constructability. With regards to structural design, we have corrugated steel pipe. It's a thin wall, it's flexible. We add the backfill to it, granular, well graded to known properties. It's compacted to a 95% minimum Proctor density, and you get the ring compression. So the two working in tandem are able to withstand the dead loads and the live loads up above. For smaller pipes from, say, 300 to 3,600 millimeter diameter, a height of cover limit tables can be used. Like you see here, this is 68 by 13 corrugations. It shows the diameter down the left, and it'll show the ratings for the Highway CL 625 and the Railway E-80 ratings, and then it will show the different gauges and then the minimum and maximum cover heights for those particular diameters. So for instance, for 300 millimeter, the minimum cover height is 300, And then when you get to 2,000, it moves to 500. And then these are the maximum covers by meter. And then over here, this is for 125 by 25. So as you get into the larger diameters, say from 1,200 to 3,600, then you can see things change again for the minimum height of covers and the maximum height of covers. With regards to structural plate, tables are pretty well not used. You're basically using, computer programs, ultimate strength principles, and the like. So I would like to turn to fish passages. There are many out there and many that work. And I'd just like to share with you a few of the what our members have done over the years with regards to fish passages. With regards to fish passages and getting through those culverts, and migration is essential for many fish species, meaning they want to go to the upper stream waters to where they were spawned, say 7 or 8 years ago, and have their families. And they have to deal with things like excessive water velocities. Sometimes the culverts are perched or sloped. So how do they get through those? Do they have to jump through? Do we help them through with ladders? Sometimes there's inadequate water depth to support fish movement. And if natural means cannot be accommodated, baffles should be used in closed culverts. So if you don't need a baffle, that's fine. Use the natural environment. But sometimes with closed culverts, baffles are required. And the primary factors to consider are fish swimming speeds. They have 3 different speeds. They have normal speeds, resting speeds, and bursting speeds. So that has to be taken into consideration. And hydrologic conditions within the culvert, like culvert length, how far do they have to swim? Are there baffles? The energy dissipation in the pools, water levels, and water velocities. So there's a number of factors that need to be taken into consideration, and especially if they are on a slope, say a 7-degree slope or 8-degree slope, they're not only swimming through these velocities of waters, but they're swimming uphill. So not easy. Here is one in Guelph, Ontario, just near the Hanlon Expressway, Highway 6 North, and it's natural. This is a culvert that's been in the ground, I believe, for close to 60 years, maybe more. It's been there a long time, but it has a natural bottom, as you can see there. And it's been, some of those stones have been placed to almost mimic a baffle type system that allows the fish to get from the downstream waters to the upstream waters. This one is in New Brunswick. Again, a different type of design, as you can see there, with the fall wag basically right in the middle between those 2 baffles. So a different design, but this one was installed in New Brunswick. Here's another one in Cape Breton, Nova Scotia, similar to the one you just saw, but a little different. And again, the fall wag is in the middle there. Here's one in Coquihalla Highway on BC. Very, very different from the ones you just saw. So again, there's so many different designs out there that are acceptable by DFO, but nevertheless, I'm sure some work maybe better than others. Nevertheless, this is another design in BC. Here's one in Toronto. And this one was being laid. They diverted the water away to be able to put this into that particular large culvert. As you can see, it's surrounded by natural bottom, and they've even put rocks in there to help with this particular baffle system, which I'm just going to talk about in the next slide. This is probably the newest one that I have seen. This was designed or developed by Ken Hannaford, who's an environmental scientist with the Newfoundland DOT. And the modeling of this was done by Jason Duguay from the University de Sherbrooke. And Dave Penny, my predecessor, was very instrumental in pushing this along and getting it out into the marketplace. And as you look at this particular baffle system, it meanders. So you have a baffle and they meander all the way down the particular culvert. So what this does is mimic the upstream waters, and it allows the fish to more or less swim around and side to side. And again, just like they're swimming in a stream down below in the downstream waters. And it has been very successful. Dave was very instrumental in getting the first job with MTO in Ontario, up in Southampton under Highway 21. And this was a kind of a jack and bore type smooth wall steel pipe that was shoved underneath that highway. And then that is polymer structural plate with those Hannaford baffles. And it's basically grouted on the outside and underneath to that steel wall. This was particularly a great test. This was the first one that was installed. I believe it was back in 2016, 2015 in that area. And there's a reserve up there, a native reserve. And the reserve had not seen fish in the upstream waters for something like 40 or 50 years. There was a smooth wall concrete structure that went underneath the highway on a 45-degree skew, and the fish just could not make it up. And so they hadn't seen fish in the upstream waters, so they tagged the fish, and it's been checked over time. And pleased to say that it works, and the fish now are able to get through that particular culvert on a 7-degree slope, through the velocities, as you can see on the picture on the right. That is Dave Penny there. He was going to, I don't know if he was going to sit down on that or whatever, but he was taking a good look at the flow over the baffles, and the fish are able to make it to the upstream water. So it's been a success. And Dave runs fishculverts.com, and he works with that particular system full time. This is what we would call a stacked pools fish ladder, not a smorgasbord for that bear. That is in Maddox Cove, Newfoundland. It is, those are two twin riveted pipes, probably about 50 years old. Maddox Cove is about 20 miles east of St. John's, Newfoundland. And the drop from those culverts to the stream down below that runs out into the Atlantic Ocean, or that bay, is probably at least, I would say, 2 meters. And there's no way the fish can jump from that stream up through those culverts. So Dave came up with a design, and unfortunately financing didn't follow through to be able to do this, but he came up with a design for a fish ladder using those particular baffle type systems, and you can see it there. And we just threw the bear in there just to have some fun. I'm going to move over to animal crossings, and then I'll turn it over to Stan. There are large structures designed for motor safety. So for instance, animals like moose, elk, and deer. Smaller culverts are designed for species conservation, like salamanders, snakes, and turtles. Fencing is used a lot to increase the effectiveness. Cameras are placed to capture animal movement to ensure that these work. The success rate in North America with fences that are used on an over or underpass is 87%. So that's pretty amazing, because you can imagine, if you get a herd of elk crossing the Trans-Canada Highway, what a catastrophe that could be for both animal and for humans. So these systems are put in place across Canada to help the animals get from one side to the other. And I'm just going to show you a few quite briefly. Here's one in New Brunswick, an underpass. Pretty simple. You can see the fencing there that is fenced off, so it's going to drive the animals underneath, and obviously not over and above the highway. This one is in Alberta, different kind. It's a little bit of an overpass, and they captured on camera that lynx, as you can see in the picture on the right. Here's one for the Banff Wildlife Crossing that was put in place, I believe, in the early 2000s. You can see a picture on the left, the construction that was starting, and then the picture on the top right there with the head walls being put in place. The picture on the left here is on the top of the structure. You can see the fencing that takes place, and a picture on the right with the westbound lanes and then the eastbound lanes and the beautiful Rockies in the background. In a finished category. And they have put cameras on here, and they've seen multiple multiple animals crossing, because all the way down that Trans-Canada Highway, there is fencing, and it is, again, is driving the animals up and over and not on. Here's one. I'm going to show you a few over in Europe. Estonia, which is in Northern Europe. Here's a picture of a crossing that they had. Here's one in Poland, much larger. But again, you can see the crossing with the fencing, again, from the two different forests on either side, again, trying to drive the large animals across. There's another one in Poland over that railway. Here's one in Poland where they captured elk going through I think that's a female in the front and a male in the back. And it's, as you can see, they're going underneath the highway. And again, it's all fenced off to try to push them to safety. And here is one in Turkey also. So they are all around the world, and especially on these major highways where herds are and animals need to get across. They're being built, and we're seeing a lot of success, which is amazing for, again, both the animal, wildlife, and for human beings. So with that, I'm going to stop sharing my screen, and Stan will come on and take over, and I will stop my video and mute and be back with you in a few minutes.
Okay, do you see my screen?
You can turn on your video as well, Stan.
Oh, yeah, hold on.
Perfect.
There we go.
All set.
Okay, so I'll start off with some background information about our company. As Ray mentioned, we're one of the world's largest steel and mining companies. We have 170,000 employees globally. We produce 83 million tons of steel annually and 118 million tons of iron ore. Our presence is in 16 countries, and our key global markets include automotive, construction, household appliances, and packaging. This is our footprint in Canada. We have large mining operations in northern Quebec, an industrial footprint in the Montreal area, and our largest mill is in Ontario, the Fasco, where I'm based today. So we employ 10,000 people in Canada and 6,000 in Ontario. So steel makes up a big share of global CO2 emissions. This is a pie chart that shows the share of CO2 emissions by sector. As you can see, that there are other sectors like transport and power that account for a larger share of carbon emissions. But for those sectors, there's a clear path to decarbonization. So for power, for instance, you have wind and hydro, which has become cheaper than generating electricity through fossil fuels. And in transportation sector, there's electrification. By 2040, the majority of cars produced will be electric, so that portion of the pie will shrink significantly. But then there's the industrial part of the pie, so the cement, oil and gas mining, and steel. This is called the hard to abate sector. It's for this sector, the path to decarbonization is a lot more hazy. It's more difficult, and steel makes up a big portion of that. This data is from McKinsey and Management Consulting Company. They pegged it at 8%. I've seen it between 7 and 10% from other studies. Anywhere you look at it, it's a very big percentage of overall global emissions. Taking a closer look at carbon emissions in the steel industry, this is by technology path. There are three major technologies, major ways of producing steel today. The largest one is the blast furnace. So this is when you take coal and reduce it with iron ore. So this is a footprint. These are global average numbers of 2.3 tons of CO2 per ton of crude steel produced. Now, if you shift to the electric arc furnace technology and you feed the electric arc furnace with 100% iron ore, that drops down to 1.5 tons of CO2 per ton of crude steel produced. And then if you feed the electric arc furnace with 100% scrap, it drops down to 0.8. Now, these are global average numbers, and so in some areas, the electrical grid is a lot cleaner than in others. So, for instance, if we feed 100% scrap into our EAF furnace in Quebec, where the grid is 100% decarbonized, that number will drop from 0.3. So I find it amazing that you can go from 3 on one end, on one extreme, all the way to 0.3, reduce the emissions by a factor of 10 for producing the same product using technology that's readily available today. We may be asking, that's great, so why don't we produce all steel by melting scrap? There's one big problem. There just isn't enough scrap available on this planet to do that. This graph shows a percentage of iron ore and scrap as it stands today. Last year we produced 2 billion tons of steel, and scrap availability was at 600 million tons. So in order to reach our net zero targets by 2050, we have to decarbonize iron ore reduction. So I'll be talking using, many of you may have heard about scope 1, 2, and 3 when it comes, or the greenhouse gas protocol basis for CO2 emission accounting. So scope 1 are direct emissions. Scope 2 are indirect emissions associated with electricity production. And scope 3 is everything else. There's a list of 15 categories that fall into scope 3, everything from purchased goods to investments to employees commuting is covered in scope 3. It's a massive list. So my focus today, I'll be talking about scope 1, which is direct emissions from our furnaces, and scope 2, the electricity emissions associated with electricity production. So on to our decarbonization story in North America. The next slide, I'll be showing our decarbonization roadmap. But before I get there, I just want to mention that we're already starting in a good position relative to the industry average. So the industry average for blast furnaces is 2,200 kilograms of CO2 per ton of steel produced. But our North American average right now is 1,500 kilograms. So we're already 30% lower because we have a significant electric arc furnace footprint already. So this is our roadmap. This is fresh off the press. We just finished this group, sustainability group finished this last week. So the first group I'm showing this to. All of our decarbonization reporting at ArcelorMittal starts uses 2018 as the baseline year. So starting in 2018, here in North America, we shut down a blast furnace here in Hamilton, so that reduced our footprint by 2%. We're increasing our capacity on our existing EAF furnaces, so that will reduce our footprint by 8%. The major first project is the installation of a new EAF at our site in Calvert in Alabama. And this slide goes into more detail about this project. It's 1.5 million ton EAF. Now, the massive investment is happening here in Hamilton. It will reduce our footprint, North American footprint, by 15%. So here's a slide that goes into more detail about this project. It's a massive $1.8 billion investment that will reduce our footprint here in Hamilton by 60%. It involves installation of a new 2.5 million ton DRI module and a 2.4 million ton electric arc furnace. So this goes into more detail. So the way we've been making steel for over 100 years here is by reducing iron in blast furnaces with the use of coal. And what we're transforming to is directly reduced iron, where the iron is reduced with natural gas, but in the future it can be easily substituted with hydrogen. And then that DRI gets fed into an electric arc furnace and results, this project, massive project, will result in a 60% reduction in our greenhouse gases. So this is a picture of our primary end. If you ever drive over the Burlington Skyway, you have a very good view of our primary operations. It's a massive industrial complex on 700 acres here in Hamilton. And you can see how dramatically our footprint will change as a result of that project. All these X's, the coke plants, the coal yard, the 3 blast furnaces, our converter, our KOBM, they'll be all eliminated and replaced by our new electric arc furnace and DRI module. So massive transformation will result in reduction of 3 million tons per year, which is the equivalent of taking 1 million cars off the road. So from 2018 to 2030, we'll reduce our North American footprint by 35%. And then there's the next step. And this is when, after 2030 is the big challenge. So this next step will our journey to net zero will be achieved through energy transformation, through the use of green hydrogen, sourcing green electricity, and steel making a transformation, new technologies like carbon capture and storage and carbon capture and utilization. This goes into more detail, but we have a team working on this project in our research department. We're calling it the next project. What comes next after our big decarbonization projects after 2030. So we're looking at everything. We're looking at hydrogen, looking at bioenergy. We're looking at electricity and electrowinning. So basically, reducing iron ore through electrolysis, similar to how aluminum is produced, and also looking at carbon capture and utilization, carbon capture and storage. Another initiative that we recently launched that's been very successful in Europe, and we're working on releasing it here in North America as well, is our XCarb initiative. So there are 2 products. First are XCarb green steel certificates. So these are carbon offsets tied to our decarbonization projects, so that they allow our customers to reduce their scope 3 emissions in their reporting. The other ones, the XCarb recycled and renewably produced product offer, where it's a green steel product produced on our electric arc furnace with very high recycled content and a completely decarbonized electric grid. So this one will be launched very shortly here at the FASCO. And finally, the third XCarb initiative is the XCarb Innovation Fund. Our company's committing $100 million a year to invest and fund to accelerate decarbonization, funding different projects. So there's some examples listed here. We're investing 10 million in a company called Heliogen, an innovative solar power company. 25 million in Form Energy, which deals with breakthrough low-cost iron air battery storage technology. Lanza Tech, which is a carbon capture and utilization company. We have a pilot project in Europe with ongoing right now with that company. We're also collaborating with several organizations. Focus on achieving net zero for the steel in the steel sector. So science-based targets and net zero initiative. So that's guidance for and standardizes net zero for the steel industry. Other groups include Mission Possible Partnership, Rocky Mountain Institute, and the Responsible Steel Carbon Initiative. I've only scratched the surface of our decarbonization initiatives at ArcelorMittal. If anyone's interested in learning more about this, we have abundance of information available on our website. If you just Google ArcelorMittal Climate Action Report or Fact Book, you'll find a lot more information about our decarbonization initiatives. So I believe that was my last slide. So I'll pass it on to you, Ray.
Thank you, Stan. If you could just stop sharing your screen, that would be great. Thank you. Thank you. Back in 2018, we undertook a study of the environmental footprint or carbon footprint of corrugated steel pipe. And we worked with a company called SCS Global. They are one of the companies in North America that do this type of work. And what they do is they look at your products, your industry, and they go from cradle to gate. And they look at everything from the production of the raw material to the transportation to the manufacturers, to the manufacturing of the product itself, to the installation, to the disposal, to end of life, whether it's recycled or sent to a landfill site. And what is produced is called an environmental product declaration, which is this document here on the left. It's about a 12-page document, and I'll show you the results in a minute. And then to follow up that, what we wanted to do is we wanted to find out how we compared against concrete pipe. Obviously, our members compete against concrete pipe manufacturers, and we wanted to see where we stood on the scale. Were we good? Were we worse? And let me just continue on here. So this is the table 2 of the results of the initial environmental product declaration. It shows the impact category down the left-hand side. Starts with global warming potential, or the carbon that you produce, all the way down to the depletion of abiotic resources or fossil fuels. And then it shows the units that it's measured in. It shows the product stage, and then obviously the end of life with reuse, recovery, recycling potential. And these are the results of the study. It took probably close to 3 or 4 months going through this. There's a lot of facts and figures that have to be captured and audited. And these are the results, as you can see. Now, they're not easy to understand. I know all of you who are watching today will understand how to calculate 1.79 times 10 to the minus 13. But to how many people out of 100 could actually calculate that and really understand what they're talking about? So I've basically done all of the calculations over the years to determine what the carbon footprint is. But just to show you in a nutshell, the results of of, just a minute here. Oh, sorry. Let me just move this out of the way because yeah. Okay. So the results of 1 metric ton of steel to produce corrugated steel pipe, the global warming potential, corrugated steel pipe would produce 1.5 tons of carbon, which is equivalent to driving that automobile 32% of the year or driving 5,907 kilometers, or heating that house a quarter of the year, 26%, or using 61 propane cylinders for your home barbecue. So I'm just trying to give you an idea of, what, say, 1 metric ton in corrugated steel pipe or structural plate equals to something else. So what we did then, after we did the study with the other company to compare ourselves to concrete, and this is where they have 3 different people study these results. You have a concrete expert, you have a steel expert, and then you have the chair, the neutral party. And they go through it and they compare and come up with more or less audit the report that the third party has done to determine where one stands versus the other. And from that, we put together an environmental calculator. It's on our website, and you can click in the diameter in millimeters, the length of the particular pipe, and it will produce the carbon footprint of CSP versus RCP, and we'll show you the differences. So right now, based upon the latest published results, corrugated steel pipe has a lower carbon footprint than concrete pipe. For this particular diameter, 300, for global warming, it's 42% less. For the fresh water that's used to produce it, it's 53% less. And for the total primary energy that's measured in megajoules that is used to produce that 1 metric ton, it's 39% less. And so again, it's out there, it's based upon published results, it's third party. And the next go round will probably be in 2023. We will do another environmental product declaration. We'll probably start at the end of this year, and it will be published in 2023. And we'll see how we've done in the last 5 years as to where we were in 2018 and where we are in 2023. Our members have undertaken, they have plans in their plants to reduce their carbon footprint, from going to electrification of, say, forklift trucks, to electrifying their plants versus, things like natural gas or propane and, those particular areas, using electric vehicles. They're all committed to becoming carbon zero by the year 2050. But plans are already in place and working each and every year to continually reduce. And as Stan said, ArcelorMittal, being the largest steel producer and mining company in the world, way ahead of the game against other steel companies, which is wonderful because they're a great partner here to us in Canada. And we should see quite a drop in our carbon footprint over the last 5 years. One last slide. I just wanted to show you that 100% of corrugated steel pipe is manufactured in Canada. The raw materials, 80 to 85% are Canadian produced. There are a couple of materials at this stage that are not available in Canada that are sourced from the United States because there has been confusion out there with some other associations saying that a lot of this stuff is imported. The fact is it is not. And when you get into structural plate, the larger, 100% of the raw material and 100% of the manufacturing takes place here in Canada. So with that, I'm going to stop sharing, send it back to Amin, and see if there's any questions that people have.
Great. Thank you very much, Ray. And thanks, Stan, for your presentations. We have a couple of questions that came in already. The first question is to you, Stan. What are the government involvements in when doing your green upgrades to reduce the CO2 directly at the plant?
Yeah, well, the big one's financial. So I believe we're getting 900 million, massive investments, both federally and provincially, for this project. I think the total cost is close to 2 billion, but yeah, the big involvement is financial.
I see. Thank you.
Hmm.
The second question is for you, Ray. The person is asking for comparing the EPDs for steel and concrete. What is the service life of the two products being compared when doing the comparison?
For this study that was done by the third party was 75 years. So they took 75 years and they looked at what, say, gauge was required in steel to give it 75 years in all types of environments, and then 75 years for concrete pipe. 75 years is a standard that's in Canada where the provinces expect anything that's buried in the ground should last 75 years material service life. So that is what was used for this study. And 75 years is, I won't say a recent phenomenon, but it basically started in the late 90s, early 2000s. Back in the 80s and 70s and 60s, nobody ever talked about, how long materials should last, and nobody even thought about what type of environments they were being put in. Whereas all that changed in the late 90s and 75 years became the norm.
You did the answer. I don't see any questions, any other questions coming in. They probably are being typed as we speak. I have a question regarding changing or from relying on natural gas and fuels to electricity. Since right now there's a huge I guess turn towards greener and more environmentally friendly ways of producing products, of using them and manufacturing them and applying them in the field. What is the effect that you think that would do on the electric grid? Would that create a sudden over demand on electricity, since most manufacturers are considering changing from natural gas and fuels to electric sources?
Yeah, it's not only manufacturing, but transportation, right? We're going to see a massive shift, right, from internal combustion engine to electric vehicles, and industry as well has to decarbonize. And the big advantage that fossil fuels have is that the energy density is great, right? So when we decarbonize and use hydrogen, we'll need massive quantities of new renewable sources of electricity. There's no doubt about that. That's the only way we can decarbonize. So massive quantities of renewable electricity capacity.
I see. Thanks. And yeah, so there was the next question was asking something similar as well. I'll go ahead and read it. In Ontario, the majority of electricity is provided or produced from nuclear energy and natural gas. You mentioned lowering carbon production by switching to production methods and staff vehicles to electric. And did you consider the increase of electrical demand will do on these nuclear and natural gas energy? Yeah, so it's a similar question.
Yeah.
And another question, another person is asking, is there a significant cost difference to the end user for the electric arc furnace produced steel versus the blast furnace produced steel? So on the end user, the municipalities, or
yeah, Today, there isn't, but what we're seeing in many countries is there's a premium that's coming into effect for what we call green steel, right? Steel that has a lower carbon footprint usually comes with a price premium, but today it's at least here in North America that premium doesn't exist yet.
I see. So it's basically the industry is being proactive and anticipating these changes. Then when the policy is there,
Yeah.
the savings, the cost savings will automatically apply.
Yeah, there's especially when down the road when we start using technologies like carbon capture and utilization, carbon capture and storage and hydrogen, it becomes really expensive. So inevitably, the price of steel will go up at that time to reflect the higher cost of production.
You. There's another question asking about professional development hours. That's a good question, given the new requirement from Professional Engineers of Ontario. Internally at Good Roads, we're working on a learning management system, and we'll make sure that all webinars be included for automated way of producing professional development hours certificates. I'll forward your request to our education department. If I'll type in my email and the answer.
Up to now, Amin, I have been issuing them for people who have attended our webinars.
Okay.
So I'll talk to you about that maybe afterwards. But yes, anybody who's attended, this webinar, say over at least 45 minutes, would get, say, 1 hour of professional development and a certificate from us.
Okay. Good.
And anybody who, jumped off early, let's say they jumped off after 30 minutes because we're able to see that, they would only get a half an hour type of thing.
That makes sense. If anyone needs their PDHs, reach out to me at amin@ogra.org, and I'll connect you with Eric and our education department. I don't see any other questions on my screen. Do you have any other comments? Do you think there are some points that you want to further clarify, either Ray or Stan?
I'd just like to, first of all, thank each and every person who attended today. Obviously, thank Stan and yourself, and to let everybody know that there will be a recording afterwards. It will be on YouTube, and once that is on there, I will send out a message to all those people who registered and also who attended that with the link that's available. Because, sometimes people register and they can't attend in person. I understand that. There's so many, everybody's busy, but they can have a chance to watch it later. But thank you very much.
Thank you, Ray. Since I don't see any more questions, so with that, this brings us to the end of today's webinar. I would like to thank Ray and Stan for taking the time out of their busy schedule to educate us about the new developments in the steel and corrugated steel industry and how it's working to reduce their carbon footprint. So thank you very much for your presentations. And I would like to thank all the attendees today for joining, and I hope we were able to provide valuable information for your time commitment. Thank you all so much, and have a wonderful day.